Hi everyone, welcome to Control System lecture series. This is lecture number 5. In the previous lecture, we are trying to cover the basic concepts of control system with the help of previous paper from GATE, IES, Pgecet. I hope it will be very useful to you to learn the basic concepts from control systems. The next concept from the control system, that is the block diagram and SFG concept. One of the very important concepts in competitive exams because maximum questions are asked in the signal flow graph and block diagram concepts to find the transfer function of the given system. And one more thing is we are focusing more on SFG because in SFG there is a formula for to find out the transfer function, single formula, that is Mason's gain formula. It is a very effective and a very useful formula in terms of competitive exams also, because if the question is given to find the transfer function, whether the system is maybe in block diagram or it may be in SFG format, we are always trying to apply Mason's gain formula to find the transfer function, because we have to learn the Mason's gain applications for the different problems. Then only the time will reduce in competitive exams. No need to bother about the block diagram reduction rules, because SFG concept is very simple and very effective concept. We can easily apply for any type of problems which are asking to find the transfer function. So we will first focus the SFG concept and basic definitions and how to apply the SFG Mason's gain formula, and later on we will move on to the block diagram and block diagram reduction rules and the basic concepts from the block diagram also, because some of the problems we ask directly from the reduction rules also. That's why you have to learn some fundamentals from the block diagram also. So let us start our discussion with SFG. So SFG is very effective and very important concept. So this is the first one is it's a comparison between block diagram and signal flow graph. On the left side we can see there is a block diagram representation with a input signal R of S and output signal C of S, and the block consists of a transfer function. That means we have a transfer function C of S by R of S is nothing but G of S. That means the output signal C of S is nothing but R of S into G of S. So same thing is represented by using SFG concept also. All the signals, that is input signal and output signal, are represented as a nodes. Input signal and output signal are represented as a nodes here. That is R of S as a node, C of S as a node, and also the gain value, block diagram consisting of transfer function, that is represented as a gain which moves from input to output. That's why we are representing a signal from input R of S node to output node C of S, and the output node value is C of S is nothing but the product of these two signals, that is R of S into G of S. That is the SFG comparison with block diagram. What are the advantages of SFG means it saves lot of time and space. By using single formula, that is Mason's gain formula, is enough to find the transfer function when compared with the block diagram, because block diagram consists of each and every step you have to redraw, and it takes more time and space also, and it is very complex method when comparing with the SFG. That's why we are preferring SFG method to solve our competitive exam papers also. And move on to the next one, that is the definitions of SFG. First definition is a node. It is a point represented as a variable. Here the node is nothing but x1, x2 and x3. x1, x2 and x3 are the nodes. Node is also can be defined as it is a combination of two or more branches. Branches is nothing but line joining between x1 and x2 and x3 and x2. These two branches, these two are called as branches with a gain value of t12 and t32. So node is also can be defined as it is a combination of two or more branches also. What is the output of x2? First thing we have to observe that the x2 node consists of two inputs. One is from x1 and another is from x3 with a gain of t12 and also t32. That's why x2 is nothing but a combination of two signals which is came from x1 to x1 and x3. So it is a combination of two signals. x2 is nothing but t1 to x1. We should multiply the gain value with a node x1 and also the second signal is t32 and x3. So this x2 is nothing but the equation with input signals which are came from the another nodes. While you are writing the x2 equation, you should consider only the input signal, don't consider the output signals from the x2 node. Only you have to focus what are the incoming signals to the particular node. Only you have to consider while writing the equations. Don't consider the output nodes. And move on to the next one, branch. Previously we discussed that is a line joining between two nodes. Is a line joining between two nodes. X1 and X2 lines are joined with a line here, and the arrow mark is from X1, X2. And the next definition is input node. Node which has only outgoing branches. Input node is nothing but a node which has only outgoing branches. Input node is also called as a source node. Source has the capability to supply the energy to the other nodes. That's why it is an input node. It consists of only outgoing branches. Source will not take any supply back here. You can call input is also as a source node. It supplies the signals. It doesn't take back the signals. Should remember, input node only consists of outgoing branches. Coming to the next definitions, output node or sync node. Output node or sync node is nothing but it consists of only incoming branches. It has only the capability to take the signals. That's why it is called as a output node or sync node. It will sync the signal. And next definition is mixed node. Mixed node is nothing but the combination of input and output. That is input signal and output signal. A particular node consists of both input signal and output signal. That particular node is nothing but a mixed node. And one more definition is transmittance. Transmittance is nothing but the gain between two nodes. We already discussed that X1 and X2 node has a particular gain value. So that gain value is nothing but a transmittance value. This is generally written on branch near the arrow. Arrow indicates the signal flow direction. Near to that we are writing the gain value. That is nothing but the transmittance of given SFG. For example, if we consider this SFG, X1 is nothing but, what is X1? X1 is input node or output node. X1 consisting of output signal only. So it is called as a source node. What about the X4? X4 has input signal and output signal. So we can say this is an mixed node here. What about the X2? X2 consists of input signal and output signal. So it is also a mixed node. What about X3? X3 consisting of two input signals and one output signal. That's why it is also a mixed node. There is no output node or sync node in this example. What is the transmittance here? Transmittance or gain is nothing but T12. T12 is a gain which has a signal direction from X1 to X2. If you want to write X2 equation, how to write the X2 equation? X2 equation by considering only the input signals which are came to X2. That's why X2 equation is nothing but X1 into T12. X1 into T12. That is the X2 equation. For example, if you want to write X3 equation, how to write X3 equation means just consider the input signal. Don't consider the output signals which are came from the X3. So just consider the input signal. What are the input signals? So X2 which is came from X2 and X4. That is, it has a two combinations of signals which came from X2 and X4. So X3 is equal to X2 T23 plus one more signal X4 T43. That is the combination of two signals for X3 node. Like that we have to consider the equations from the SFG. Next one is path. What is a path? It is traverse of connection of branches in the direction of branch arrow such that no node is traversed more than once. You should remember that last time no node is traversed more than once. A forward path is nothing but a path which is a signal travels from input node to output node. A path which travels, or a signal, you can say a signal which travels from input node to output node without any repetition of nodes. You should remember the forward path definitions because it is very, very important while considering the transfer function problems based on SFG. That means that traveling signal will be only in one direction only. One direction from input to output without repeating any nodes. Next one, forward path gain. What is a forward path gain? Forward path gain is nothing but, previously we discussed that forward path. Forward path is a signal travel from input to output without repeating any node. Path gain means you should product all the gain values while traveling the signal from input node to output. You should product all the gain values from input node to output node. While traveling from input node to output node, you should product all the gain values through the path. That is nothing but a forward path. For example, if you consider this the diagram for reference purpose, I am considering here. R of S is an input node because it has only output signals. What about C of S? C of S consists of only incoming signal. That's why it is an output node and R of S is an input node. and identify the forward paths from here. Forward path is nothing but a signal travels from input node to output node. That's why you have to consider from input node to output node. What is the path here? Through G1 you can travel, or you can travel by G5 also. First we will go by G1. So if you travel through G1 and you can move through G2 because H2 direction is opposite, so no need to consider here. You have to move forward. So G1, G2, G3 and G4. It will reach us output node. There is no repetition of any nodes here. Only one node we are considering at every time. From G1, G2, G3 and G4, that is the forward path. What about another forward path through G5, G5, G6, G7 and G8. Okay. For example, if you consider a path direction from G1 to G2, if you move through H2 means it will again go back to the previous node. So don't consider this is a forward path because the node is again repeating here. That's why it is not a forward path here. The forward path is G1, G2, G3 and G4. This is the exact forward path. There is no repetition of any nodes here. Similarly, another forward path is G5, G6, G7, G8. What is the forward path gain? We have only possible of two forward path gains. That is P1 value, first forward path gain is through G1, G1, G2, G3. Product all the gain values, you will get the first forward path gain. And the next one is through G5, G5, G6, G7, G8. This is the second forward path gain. Next definition is loop. What is a loop? The path that originates and terminates at the same node and along with no other node is traversed more than once. The path is originated and terminated at the same node. We have to close the loop. We are starting from a node and we are traveling through a path and again we are coming back to the same node only. That is nothing but a loop. That is nothing but a loop. And here also you should remember that there is no repetition of any nodes here. That is nothing but a loop. What about the self loop? Self loop is nothing but it consists of only one node. So the same node is an originated node and it is also a terminated node. The signal starts from the single node and it ends at the same node only. And it ends at the same node only. There is no more than one nodes in that path. That is nothing but a self loop. What about the loop gain? Gain is nothing but producting of all the gain values while tracing the loop path. What about the non-touching loops? Non-touching. Non-touching means there is no connection between the loops. That is nothing but non-touching loops. Or you can define like this. There is no common node between any two loops. Then that loops are called as non-touching loops. There is no any common node between any loops. Then that loops are called as non-touching loops. For example, consider this SFG. Here there is a three possible loops, including self loop also. For example, L1, L2, L3. L1 is nothing but we travel from this node through G2 and again go back through H2 and reaching the same node. What is the loop gain here? Product of gain values while tracing this loop. Product of gain values means G2, H2. That's why L1 gain is nothing but G2, H2. What about L2? L2 consisting of only one node. That's why it is a self loop. It is a self loop. What about the gain value? L2 gain value is H3 because it consists of only H3 only. So single node. So self loop gain value is H3. What about L3? L3 travels through G7 and again go back to H7 and reaches the same node. That's why there is a closed path here. So gain value is G7 and H7. R of S is the input node and C of S is the output node. These three loops are non-touching loops only because there is no common node between any loop. For example, if you consider L1, L2, there is no common node between these L1 and L2. So it is a non-touching loop. And similarly, if you compare L1 with L3, there is no common node between L1 and L3. There is no common node. That's why it is a non-touching loop. Similarly, if you compare L2 with L3, there is no common node. So all the three loops are non-touching loops only. If you compare L1 with L2, it is a non-touching loop. Similarly, if you compare L1 with L3, it is also a non-touching loop. And L2 comparing with L3 also, it is a non-touching loop. So in this example, three non-touching loops are possible. Combination is L1, L2, L1, L3 and L2, L3. If you want the gain values of these non-touching loops, just product the gain values of L1 and L2. That is L1, L2 is nothing but G2, H2 into H3. This is the gain value of first non-touching loop. Second non-touching loop is nothing but L1 and L3. So just product these gain values, you will get the gain value of non-touching loop, second combination. And the third combination is L2 and L3. just product these gain values h3 into g7 h7. It is a gain value of third combination of non-touching loops. Every time we are comparing two loops, that's why it is a two non-touching loop. The possible of two non-touching loops are 3 in this case. Every time we are comparing two loops only. That's why two non-touching loop combinations possible for these SFG are 3. How many combinations are possible? L1, L2, L1, L3, L2, L3. So 3 combinations are possible. Hence, 3 combinations are possible in 2 non-touching loops. 2 non-touching loops means we are comparing every time 2 loops. Okay. What about 3 non-touching loops? How many 3 non-touching loops possible? 3 non-touching loops means we have L1, L2, L3. So we have only 3 loops. All the 3 loops doesn't contains any common node. That's why. So 3 non-touching loops are possible in this case of SFG. That is only one combination. That is L1, L2, L3. If you want the gain values, just product these 3 gain values. L1, L2, L3. Product these gain values. That is G2, H2, H3, G7, H7. So it is the gain value of 3 non-touching loops. I hope this will be clear to you. This is the example of all the definitions which we already discussed in SFG. So it consists of all the x1 is nothing but input node or source node, x is nothing but output node or sink node. What about the mixed nodes? Mixed nodes consisting of input signal and output signal. So this is a mixed node and one more mixed node here. This is a mixed node. It consists of input and output signals. And we have one more input node here, x4. Because it consists of only output signal, so it is also considered as an input node or a source node. So in this SFG, we have 2 input nodes or source nodes, only one output node or sink node. What about the forward path? We have 2 inputs. That's why there is a possible of 2 forward paths. First forward path will start from x1 and reaches to output node. Similarly, next forward path will start from x4 and reaches to x3. So this is the path of next forward path, and first forward path will start from x1 and reaches to x3. So this is the forward path. What about the gain values? The first forward path which starts from x1 to x3. The gain values are a into b into 1. A into b into 1. Because these are the gain values or transmittance values. What about the next second forward path gain values? Which starts from x4 to x3. So gain values d and 1. So multiply this one. D into 1. D is the gain value for the second forward. What about the loop? There is only one possible closed loop here, which starts from x2, x3 and again reaches to x2. So this is the closed loop here. What about the loop gain value? In this tracing the loop gain, what are the gain values here? B and C. So multiply these two. B into C is nothing but the loop gain values. I hope this will be clear to you. Move on to the next one. Another important concept in SFG, that is Mason's gain formula. This formula is very, very important and you should understand each and every term. What is the Mason's gain formula here? Mason's gain formula is applicable only to find the transfer function of the given system. Whether it may be in block diagram or it may be represented in SFG format also. Just this applicable to find the transfer function only. What is the formula here? G of S is the transfer function, or there is nothing but C of S by R of S is equal to summation of K, Pk and delta. What is K represents here? K is nothing but number of forward paths. And there is a denominator delta also. Okay, we'll see one by one. K is nothing but number of forward paths. Pk is nothing but the kth forward path gain. What about delta? Delta is nothing but denominator term 1 minus sum of loop gains. Sum of loop gains. That means you have to add all the loops which are framed in the SFG. It includes self loops also. You should add all the loops which are available in the given SFG. So 1 minus sum of all loops plus, and next one is minus combination. So if you see, alternatively there is minus, plus and minus. So first one is sum of all loops. You should add all the loops. And next combination is sum of non-touching loop gains taken 2 at a time. That is 2 non-touching loops. How many 2 non-touching loops are possible? And that gain values we have to sum here. Third term we have to add here. Okay. And the next one is sum of non-touching loop gains taken 3 at a time. Sum of non-touching loop gains taken 3 at a time. That is 3 non-touching loop combinations you have to verify, and you have to add all the gain value. How many combinations are possible, and you have to add all the value, and plus so on. In maximum competitive exam questions, delta value will limited to first 2 terms only. That means 1 minus summation of loop gains. Problem will be simplified if there is a touching loops. Maximum problems in the competitive exam, they will not go for third and fourth terms, because there is no possible for non-touching loops in the combination of 2 at a time or in the combination of 3 at a time. So maximum problems you will solve by using only 2 terms, that is 1 minus sum of all loops. But we have to identify what are the loops and what are the non-touching loops. It should be very clear, then only you can understand. the application of Mason's gain. Okay, I think this will be clear to you. Delta will be the summation of 1 minus summation of all loops plus summation of 2 non-touching loops minus summation of 3 non-touching loops and plus summation of 4 non-touching loops and so on. K is nothing but the number of forward paths. Delta K is nothing but 1 minus loop gain which does not touch the forward path. That means you have to consider which loop does not touch that selected forward path. K is nothing but forward path. For example, if you consider a first forward path, in that first forward path, you have to identify is there any loops which does not touch that first forward path. That gain value we have to include here. So remember, loop gain which does not touch the forward. So if you are very clear with this equation, then it will be very useful and very easy to apply this Mason's gain formula for any type of questions in the competitive exams, whether it may be a block diagram representation or it may be SFG representation. For example, K is equal to 3 means the numerator will consist of P1 delta 1 plus P2 delta 2 plus P3 delta 3 by denominator consists of delta value. So first question is we have to identify the loops from the given SFG. Complete self loop and closed loops we have to identify from this SFG. This is the SFG diagram. How many loops are possible? Loop means there is a compulsorily there is a feedback. Loop means there is a return signal for the same node. Return signal for the same node. Shortcut is only simple thing is we have to identify return signals or feedback signals. Okay. So in this entire SFG, the return signals are A32, which is came from Y3 to Y2, and one more thing is A43, which is came from Y4 to Y3, and this is also a self loop here because it consists of only one node. So it is also a loop here. Just identifying, we have 3 return signals, and how many forward signals we have from input to output. Forward signals means it represents the forward paths. Okay, forward direction signals. Y1 is the input node, Y5 is the output node. So how many forward signals we have? From Y1 to Y2 and Y2 to Y3 and Y3 to Y4 and it reaches Y5. This is one first straight forward path. And one more forward path is it deviates at Y2. We have 2 deviations here. So at Y2 we have A24 and reaches Y4 and reaches to Y5. And next one is from Y2 to Y5. Y2 to Y5. Directly we have A25 again. So how many forward paths in this SFG means we have 3 forward paths which travels from Y1, Y2, Y3, Y4, Y5, straight one. And the next one is Y1, Y2, Y4 through A24 gain and reaches Y5, second forward path. And third one is which travels from Y1, Y2 and directly it reaches to Y5 through A24. So SFG consists of 3 forward path gains. How many loops we have? So directly we will already check the return paths. So there is a possible of loop here. If you check here from Y2, the signal starts Y2 and reaches Y3 and coming back again to the Y2 because loop consists of the same starting and ending nodes are same. That's why the signal is ending again from Y2. So this is the first loop we can consider from which starts from Y2, Y3 and again reaches to Y2. This is the first loop. What about the second loop means? Here we can see the return path. That's why there is a possible of another loop here. So Y3, Y4 and it again comes back to Y3. So this is the another loop possible. And self loop is Y4 to Y4 only, gain value of A44. These are the basic loops. If you clearly observe the SFG, there is one more possible of loop here. If you see Y2, the signal is traveled from Y2 through A24 gain, then it reaches Y4, and the signal is again coming back through A43 and reaches Y3. And it again coming back to Y2 through A32. That's why there is one more loop is possible through Y2, Y4, Y3 and Y2. There is no repetition of any nodes. Starting and ending nodes are same. Which starts the signal at Y2 and the same signal ends at Y2. Another nodes are not repeating here. Single nodes are appearing here. That's why there is a possible of another loop here. These are the possible loops here. How many loops are possible means we have 3 loops are possible with, and also a self loop is possible. Totally 4 loops we have. So 4 loops are possible in this given SFG and 3 forward paths are possible in the given SFG. What about the loop conditions? Whether it is touching or non-touching. If you see L1, for example, if we consider Y2, Y3 and it is again coming back to Y2. So it is L1 and this loop is L2 and this one is L3. If you compare two loops L1, L2, it has common node. That's why these two loops are touching loops. If you compare L1 with L3, it does not consist of common loop because L1 loop consists of Y2, Y3 and Y2, whereas L3 consists of only Y4 only. So there is no common node here. That's why L1, L3 are non-touching loops. What about L4, which is already formed with a heart shape here? Y2, Y4, Y3 and coming back to Y2. If you compare L1 with L4, there is a touching loop because Y2 is a common node for L1 and L4. L2 and L3, this is L2 and L3 is a common node. So it is also a touching loop. What about L2 and L4? L2 and L4, it is also a common node of Y4. So only thing possible is two non-touching loops are L1 and L3 are non-touching loops. L1 and L3 are non-touching loops. What about three non-touching loops? There is no possible of three non-touching loops because if you compare L1, L2, L3, there is a common node here Y4. Similarly, if you compare L1, L2 and L4, there is a common node here Y2. So all the three non-touching loops are not possible for this given SFG. Same thing I am representing here. So these are the loops we have for this SFG. So L1 is the first loop, L2 is the second loop, L3 is the third loop, L4 is the which is a heart-shaped loop, L4 is a fourth loop. So all these loops are possible for the given SFG. And how many forward paths means there is only 3 forward paths. And next question is identifying paths loops for the given SFG. For this SFG, you have to identify the paths and loops. Same example previously we discussed in the definitions. Here we have possible of which passes through G1, G2, G3, G4 is the first forward path. And one more forward path is G5, G6, G7, G8. So 2 forward paths are there. How many loops means we have 4 loops. What of the condition of these loops? L1, L2 are touching loops. L1, L3 are non-touching loops because there is no common node. L1, L4 are non-touching loops. With the combination of L1, we have 2 possible of non-touching loops. What about the combination of L2? L2 comparing with L3, it is also a non-touching loop. L2 comparing with L4, it is also a non-touching loop. So with the combination of L2, another 2 more possible combinations. What about L3? L3 comparing with L4 means there is a common node. So there is no possible of non-touching loops. So totally we have 4 non-touching loops. 4 non-touching loops when comparing with a set of 2 loops. So this is the solution for the question. We have 2 forward paths with the gain values. And what about the loops? We have individual loops here, L1, L2, L3, L4 and non-touching loops. Just now we compared L1 with L2. There is a common node here. So it is a touching loop, but we need a non-touching loop. So when comparing with L1 and with L3, there is a combination L1, L3 and L4, L1, L4. When comparing with L2, L2, L3 and L2, L4 is another set of combination. So if you want to find out the transfer function, you can apply the formula also. And I'm not explaining right now. Just apply the Mason's-Gain formula and go through this. You will get the same thing. Let us discuss the previous papers. First question is from GATE EC 2010 paper. What is the question? See, the question is find the transfer function of the given system. The given system is represented in block diagram, but I am applying SFG concept, that is Mason's-Gain concept, to find out the transfer function, because we have to practice more and more problems based upon the applications of Mason's-Gain. Then only we have to understand how to apply in a short time to find the transfer function. Okay, this is the Mason's-Gain formula. We have to recollect K is nothing but number of forward paths, Pk and delta K. Pk is nothing but a kth forward path gain value. Delta K is nothing but 1 minus loop gain which does not touch in the forward path. What about the delta? Delta is nothing but 1 minus sum of loop gains plus sum of 2 non-touching loops minus sum of 3 non-touching loops and so on. This is the Mason's-Gain formula. So for the first problem, I am considering step-by-step procedure. Competitive exam, directly you have to apply the transfer. That much of practice you have to learn by doing lot of problems. So this is the explanation for that question. First I am identifying number of forward paths. So K indicates the number of forward paths. In this question, only one forward path is possible. The signal is traveled from input to output only in one direction. If you consider R of S as input and Y of S as output, so the signal is traveled from R of S to Y of S through 1 by S plus 1 gain block. If you consider the bottom one, 1 by S plus 1, the signal will travel up to the summing point. After the summing point, the signal will not travel to Y of S. It is coming back to the R of S summing point. That's why it is not a forward path. So don't consider this one as a second forward path. Just we have to consider only one forward path in the given question because the signal is traveled from R of s to Y of s only in one direction. The signal arrow mark indicates the signal flow direction. So it indicates only one forward path. K equal to 1. What about the gain value? In this direction, the gain value is 1 by P1 is nothing but 1 by S plus 1. Okay, next step is identifying the number of loops. Loop is nothing but the starting node and the ending node are same. Starting node and ending node are same. Then it will be considered as a loop without any repetition of nodes. So first loop is the outer loop I am considering here. From this summing point, the signal is traveling like this, and it reaches to the another summing point, and it again coming back from the summing point and reaches to the same summing point of R of s. So this is considered as a closed loop here. What about the gain values? Gain values is passes through 1 by s plus 1 block, 1 by s plus 1 block. So consider this gain value into, and the signal coming back to R of s input. Here the signal feedback is negative. So you should consider the minus 1 here because the feedback signal is minus 1. If it is a plus, you should consider plus 1. So here the signal feedback is minus 1. So consider this value as a gain of minus 1 value. So the gain L1 loop gain is nothing but minus 1 by s plus 1 because multiplying of 1 by s plus 1 into minus 1 will give the same value. L1 gain is nothing but minus 1 by s plus 1. What about the second loop? If you travel the inner loop here, inner loop starting from R of s summing point, it travels through 1 by s plus 1 and it again reaches the summing point with a gain value of minus 1. So minus 1 means should product this 1 by s plus 1 into minus 1 and it again coming back to R of s with a negative signal. That's why again we have to multiply with minus 1. So totally the L2 gain value is nothing but plus 1 by s plus 1. So the gain values are L2 gain. I am representing here the inner loop. So the inner loop represents the L2 loop with the gain values 1 by s plus 1 into minus 1 here and one more minus 1 here. So with this we are identifying number of forward paths and number of loops. What about the touching loops and non-touching loops here? L1 loop is nothing but the outer loop. L2 loop is nothing but the inner loop. Both the loops will start from the same node and end at the same node. So both are touching loops. There is no possible of non-touching loops. That's why delta is nothing but 1 minus sum of all loops. First summation is sum of all loops. We have to sum all the loops. And the next combination is plus 2 non-touching loops. Here all are touching loops only. That's why the values is zeros here. So only thing is delta is nothing but 1 minus L1 plus L2. 1 minus L1 plus L2. What about L1 plus L2? L1 is nothing but minus 1 by s plus 1. L2 is nothing but plus 1 by s plus 1. If you add these two, it will produce a 0 value. That's why delta is nothing but 1. What about delta 1? Delta 1 is nothing but 1. 1 minus, we have to identify which loop does not touches the first forward path. In this SFG, we have only one forward path. In that direction, all the loops are touching. We have only two loops. Two loops are touching loops only. In the first forward path, L1 has common node input error detector and L2 is also has common node input error detector. So in the first forward path, L1, L2 both are touching only. So consider delta 1 is equal to 1 minus 0. It produces 1 only. So now applying the transfer function Mason's gain formula here, P1 delta 1 because we have only one forward path. P1 delta 1 by delta is equal to 1 by s plus 1. 1 by s plus 1. If you substitute all these values, you will get the same thing. So the answer is 1 by s plus 1. This is the second question from GATE EC 2010 paper. What is the question here? For the signal flow graph, we have to identify the transfer function. First thing, we have to identify the number of forward paths. How many number of forward paths we have? In this question, we have two possible forward paths. P1, which travels from A, B, C, D, E. A, B, C, D, E are the nodes here. A, B, C, D, E, F, the straight one. And the next forward path is A, B, C, and directly jumps to E. And one more forward path here and reaches to F. So the gain values of first and second forward paths are P1 is nothing but 2 into first forward path is straight one, 2 into 1 by S into 1 by s into 1 into 0.5. That will produces 1 by s square. What about the next second forward path? 2 into 1 by s into 1 into 0.5. That will use 1 by s. So 2 forward path given values. What about the loops which consists of feedback, return path? We have 2 return paths here. So there is a possible of 2 loops here. First loop is which starts from C and reaches to D and it again coming back to D value. So this is the first loop. C, D, C. Same nodes. C starts from C and reaches to D and again coming back to C. What is the gain value here? 1 by s into minus 1. So minus 1 by s. What about the second loop? Which starts from B and reaches to C and reaches to D and it again coming back to D value. So what is the gain value? 1 by s into 1 by s into minus 1. So 2 loops are possible and the value is minus 1 by s square. And there is no more possible of loops here. All these 2 loops are touching only because there is a common node of D. L1 and L2 has common node of D. So all the 2 loops are touching. There is no possible of non-touching loops. So don't bother about that. So only 2 loops are possible. For example, if we consider B, C and D through this minus 1, but minus 1 has opposite direction of signal flow. So don't consider this is a loop here. So because it has opposite direction of minus flow. If we consider from B to C, the signal flows from B to C. After C to D, don't consider minus 1 as a path because it has opposite direction of flow of current. So it will not create any closed loop here. It will not create any closed loop. So it has only possible of 2 loops, L1 and L2 with a gain of minus 1 by s and minus 1 by s square. What about the transfer function based upon the Mason's gain? Summation of pk delta k by delta. So k is nothing but 2 forward path. So numerator part we have p1 delta 2 plus p2 delta 2 and denominator part delta value. So first find out the delta value. Delta value doesn't consist of any non-touching loops. So just 1 minus sum of all loops. 1 minus sum of all loops. It produces the same value 1 plus 1 by s plus 1 by s square. What about the delta 1 and delta 2? Delta 1 and delta 2 is nothing but 1 minus, is there any loop which does not touch the first forward path? Similarly, we have to identify, is there any loop which does not touches the second forward path? But here, all the L1 and L2 loops touching both the first and second forward path. If you consider the straight forward path, L1 and L2 will touches the same forward path. Similarly, if you consider the second forward path, it will also touches the second forward path because it has common node C and D. So there is no possible of touching loops. That's why delta 1 and delta 2 values are 1 only. So don't consider this one is wrong indication here. Delta 1 is 1 and delta 2 is also 1. So don't consider it is a 2 because it is 1. Because all are touching in the first and second forward path. If you consider this is the first forward path, L1 and L2 loops are touching here. If you consider the second forward path, L1 and L2 both are touching. So both are touching, delta 1 and delta 2 are 1 value only. What about the transfer function? We substitute p1 delta 1 and p2 delta 2 by delta. So 1 by s square into 1 delta 1 value plus 1 by s into delta 2 value 1. If you replace all these things, we get 1 by s by s square plus s plus 1. This is the transfer function for the given SFG. This is the gate question EC 2010 paper. The next question is SFG for the system given below. This is a gate question 2013 paper. We need to identify the transfer function. So first identify the number of loops and also number of forward paths. So this is the procedure for this. 2 forward paths are possible for the given SFG. First forward path is from A to B and C and it reaches D through a gain value 1 and again it reaches to E with a gain value 1. So the first forward path gain is 1 into 1 by S into 1 into 1 by S. So this is the value of first forward path gain. Second forward path is straight one from input to output. So A to B and B to C and it passes directly to D with a gain of 1 by S and reaches to E value. This is the second forward path with a gain value. So 1 by S square here. 1 by S square. That is the value of gain for the second forward path. And what about the loops here? C, D, C. C, D, C will form a loop with a gain value minus 4 by S and one more loop is upper part that is C to D and it reaches C again with a gain of minus 4. There is one more loop here. There is a closed circle here which forms with a node C D, and again it reaches to C value with a gain value 1 into minus 4. So one more loop possible here, which starts from B and reaches to C, and directly it jumps to D with a gain value 1, and it again coming back to minus 2 and reaches to D. So minus 2 is the feedback here. And one more loop is also possible, L4 loop, that is which travels straight away from D to C and C to D with a gain value 1 by S and reaches coming back to minus 2. That means with a combination of minus 4 there is a possible of 2 loops. With a combination of minus 2 there is a possible of 2 more loops, because we have feedbacks here, 2 feedbacks and 2 forward paths. So there is a possible of 4 combination of loops. First loop is minus 4 gain value, second loop is minus 4 by S, and third loop is minus 2 by S, and fourth loop gain value is minus 2 by S square. So these are the 4 loops. What about the delta 1 and delta 2 values? All the 4 loops are touching loops only, because each and every loops are touching each other. So all the 4 loops are touching each other. So these delta 1 and delta 2 are considered as 1. And also there is no possible of non-touching loops. All the loops are touching loops only. With that we can write the transfer function P1 delta 1 plus P2 delta 2 by 1 minus sum of all loops. There is possible of 4 loops. So add all the 4 loops. We will get the transfer function S plus 1 by 5S square plus 6S plus 2. So the option is A. And the next question from GATE paper 2017. What we need to find out is, we need to find out a transfer function. But here they mentioned that there is a 2 inputs U1 and U2. And we need to find out the transfer function Y of S by U1 of S. By considering the input signal U1 of S, we have to find out the transfer function. That means indirectly U of S is 0. U of S is 0. So we should assume U of S value 0. With that we will get the transfer function Y of S by U1 of S. Just practice this one. We will get transfer function K1 by JLS square plus RJS plus K1 K2. The option A will be the answer for this question. Just practice this one. And next question is from Pgecet paper EC 2018 paper. What is the question here? Signal flow graph, we have to identify the transfer function Y by X. Y is the output and X is the input. So we need to find out the transfer function. How many forward paths for this simple SFG? We have only one forward path with a gain of 5 into 2 into 1. 5 into 2 into 1. So the gain value for first forward path is 5 into 2 into 1. So P1 delta 1. We have only one forward path. So we have only numerator part P1 delta 1. P1 value is 10. What about the delta 1 value? Delta 1 is nothing but 1 minus the loop which is not touching in that forward path. But here we have only one possible loop which is also touching the first forward path. That's why delta 1 value is also 1. So the numerator part P1 delta 1 is nothing but 10 into 1. 10 into 1 means numerator will be 10 by, what about delta? Delta is nothing but 1 minus sum of all loops. 1 minus sum of all loops means we have only one possible loop here with a gain of 2 into minus 2. That is minus 4. So 1 minus of minus 4. It will give 5 value. So numerator already have 10 by 5. 10 by 5. The answer will be 2 is the answer. So for that we have an explanation here. So 10 by 5 is nothing but 2. So option 3 is the answer for this given SFG. Like this we have to practice. No need to write the Mason's gain formula each and every time in competitive exam. It will take more time. Just we have to practice more problems to directly apply the Mason's gain formula by looking at the SFG question. So likewise we have to practice more problems and its applications of Mason's gain. This is one more example for your understanding purpose. The question is to identify the transfer function only for the given block diagram. First we have to consider the block diagram as an SFG. No need to draw this diagram also. You can directly consider the number of forward paths and number of closed loops. So for this question, we have to practice and verify these answers. Whether these answers are correct or not, we have to verify. For your reference purpose, I am drawing here SFG also. So just go through this block diagram and SFG conversions and how you are considering these negative symbols. Summing point has plus and minus, and we are considering these negative symbols also for the gain value. If you look at this H1 has a signal feedback which feedback to through two summing points, which has one is negative and one is positive. So we have to consider minus H1 and we have to consider the plus H1 for another summing point. So for your reference purpose, I am giving this SFG also. Just practice this SFG and verify this transfer function is obtaining for this given example. I hope the SFG concept will be very clear. If you practice more and more problems, it will be very useful to solve the problems within a short time. Thank you. Thank you everyone. Don't forget to